Alright, today we're going to do inverse function notes. And to review, do you guys remember if I asked you for sine of pi over 3 or cosine at 4 pi over 3, and the third one I want to talk about is tangent at 5 pi over 6. This is just kind of making sure you're on the right page. Okay, so use your unit circle and tell me what you got for the first one. In other words, you're going to take a look at it and say, all right, I wanted sine at pi over 3. So you find pi over 3 on your unit circle, and this is cosine and sine. Did y'all see it? Remember, going around the unit circle, the x value is cosine. So you could march your whole way around. And then on this side, you got to be careful. Which one over here is the outsides on this side because we're backwards, right? These are ordered pairs. So the answer then is what? Root 3 over 2? Excellent. Okay, now go to number 2. Cosine at 4 pi over 3. 4 pi over 3 is down here on the unit circle. And this is cosine and sine. So what's the answer then? It's right here. Cosine. So negative 1/2, right? And what did you guys get for the last one? What's tangent at 5 over 6? What? Okay. You have to find 5 pi over 6, which is in quadrant 2. Tangent. Tangent is y divided by x. So 1/2 divided by root 3 over 2 is negative root 3 over 3. It's on your unit circle. Those are those values out there. And you'll notice that there's only 3 different values because 1/2 divided by root 3 over 3, it doesn't matter if I do it here or here, I'm going to get the same answer. The only difference is the sign, right? So that's why it's root 3 over 3 here and here. Okay, moving right along. We've studied inverse functions before. What did finding an inverse mean? Do you remember? Switching what two things. You do in algebra 2, and we did it in pre-calculus. Inverse, what does it mean? Nobody remembers? Come on. Switching what two things? Switching the x and the x and the y. Okay, that's what an inverse does. When you switch x and y, that's finding an inverse. Okay? So you switch the x and y value. And what I mean by that is, for example, if I told you sine of 30 degrees equal 1/2, right? We get that straight from a unit circle, right? So the input then is x, and the output we consider y, right? And that's exactly what I'm going to do. Today, if I had told you, if you go to sine of 30, so sine of pi over 6, let's change this 30 to pi over 6, and I'll show you what I'm talking about. Okay, that matches more like what we were talking about a second ago. So if I give you sine pi over 6, you find for me 1/2, right? If I switch the domain and range, in other words, I gave you a radian value, right? And you gave me an output, right? A point where it was. Now, if I trade them, it turns into an inverse, and I say the inverse of 1/2 equals pi over 6. Right? So let's think about that for a second. go find 1/2, right, on the unit circle. It's in a lot of places, right? And I'll explain how to know which one. In other words, if I give you the outside value, what did you give me now? I say, guys, sine here gives me what radian? This, right? Okay, go ahead. Yeah, he's making a great point. But wait a minute. If you look at your unit circle, there's more than one sine being 1/2, right? Sine is 1/2 here, and it's also 1/2 where else? Over here. Okay? There's a problem with an inverse, isn't there? I can't be in two spots. It's a great connection to me. So let me explain what happens. All right? We know that it's not a function if it's there twice, right? Okay, so this is what happens, exactly that. There's a problem. So when you find the inverse of cosine, or you find the inverse of sine, or you find the inverse of tangent, you have to use a restriction. Otherwise, it's not a function. Okay? Do you guys remember we talked about how we knew a function? Okay, this is going to take a leap, so listen for a second. We did this little trick, and we said, all right, if I take the inverse of something, and I want to know if its inverse is a function, it had to pass the horizontal line test, or the vertical line test. Remember that? The vertical line test is just, hey, am I a function? So you could look at something like this, for example, v, okay? And I would say, guys, is that a function? And you would check, does it pass the vertical line test? Yes. Then if I said to you, well, is its inverse a function? I don't know. What was the test to check? The horizontal. So watch, when I take the horizontal, does it pass the horizontal line test? No. So the inverse of v isn't a function. That's what's going on here. Okay, sine might be a function, right? The graph of sine, okay, a curve, a cosine or sine, it's a function. It passes every vertical line test we have. But is its inverse a function? Does it pass the horizontal line test? No. You see what I'm saying? So what they did is they took it, part of it will. They're going to restrict its spot that it's allowed to be at. Okay? So part of the graph does have an inverse, just not the whole graph. Let me show you what I'm talking about. So do me a favor, just really quickly, and say, all right, y equals cosine of x. Right? Then sketch for me. And if it was for a true graph, I'd need to label everything, right? Okay, just for time though, I'm going to say, all right, I know that this is pi, okay, and this is 0 because I'm going to need those. And I want to show you something. Here's another color here. Right? If you look at this, if I just take a part of the graph, and we're going to use this positive part for a second, just this part of the graph. Maybe I should use a highlighter. Just a little bit of it. So in other words, from 0 to pi. Okay, if I use just from 0 to pi, am I going to pass a horizontal line test? Yeah. So then that means if you just use 0 to pi on cosine, would its inverse be a function? Yes. So there's a restriction on cosine. Okay? When you're finding an inverse of cosine, in other words, if you're going to switch the x and y's, in other words, if I give you an outside value, right, a point, and you have to give me a radian, right, then if you're talking about cosine, I'm only allowed from 0 to pi. Think about your unit circle. 0 to pi is which two quadrants? 1 and 2. So cosine is only allowed to come from here if you're finding its inverse. Because if you get into quadrants 3 and 4, that you get more of that graph, right? The hill goes back up and the hill goes back down, and then all of a sudden we no longer pass a horizontal line test, right? Okay, so then that's all we get. If you're finding the inverse of cosine, what two quadrants are you allowed to look at? Quadrants 1 and quadrant 2. Okay, same thing with sine. You can only take a little piece of the sine graph, all right? And the 2 quadrants that sine would fall in to make it work are actually quadrants 1 and 4. Okay? Now here's the weird thing, and we'll get to this in a second. So if I'm sine, what happens if, and I'm going to talk about this a little bit more in a second, what happens if I want to go down here to an angle and I'm sine? I want to take the inverse of sine. Am I allowed to go in quadrants 2 and 3 to get to here? I'm not even allowed over here, am I? Okay, so if I want to get to sine and I'm down here, I either go up to quadrant here, which will be from 0 to 90, or I've got to go down, which is from 0 to negative 90. Okay, you can't call these over here 11 pi to 6, 7 pi to 4, and 5 pi to 3, because that meant you went all the way, 1 pi, 2 pi, 3, you went all the way around to get there, right? If I call this pi over 6, negative pi over 6, pi over 4, negative pi over 4, right? If I call this negative pi over 6, what did it mean? The negative tells me the direction, right? And then I went straight down to get there. Okay? Alright, so let's actually try a few problems. This is important. So box that. You need to know this. This is where you're allowed to be if you're finding an inverse. Right? In order for the inverse to be a function, you have to stay in these quadrants. Cosine's allowed here and here, and sine is allowed in 1 and 4. Got it? Alright, let's give it a try. I'm going to put my unit circle up here because it makes this easier. So give me 1 second to get it right. Alright. I'm actually just going to write up on the board today. Okay, number 1. Let's try it. So the first thing I want to ask you is for you to find the inverse, and they capitalize T for the inverse. Inverse cosine of root 2 over 2. Keep in mind, cosine is allowed here and here, and sine is allowed here and here. That's it. You're not going to look anywhere else. It's the inverse cosine. That means that little negative 1 means I'm going to shop on the outside, right? I'm giving you the y value. So if you find it here, here are the y values that we're allowed to use. Which one fits the root 2 over 2 criteria? Here. Agreed? I gave you the outside value. What radian is that at then? Pi over 4. Excellent. Oh, no wonder y'all looking at me funny. Guys, if you're watching the video, I'm sorry. I put Y's. Thank you. I should have been here. Thank you. Thanks. So cosines. I apologize. And you want the inverse cosine. So again, we just got lucky. We stopped in the same spot. And it's pi over 4. Okay? So you write pi over 4. That's your answer. Yeah. We went the other way, right? Because before, I was asking you, all right, guys, what's cosine at pi over 6? And you would tell me the cosine value. Right now, I'm saying I'm giving you something on the outside, and you're giving me a radian. Okay? I'm reversing it. And the reason I know I'm reversing it is the negative 1. It tells me. Which also tells me there's restrictions. Okay? All right, let's try again. Sorry about that mistake. Number 2. Let's do cosine, the inverse cosine of negative 1/2. I'll give you a second to think about it. Look at your cosine values. Where you're allowed. But think about it. It's the x-axis, guys. Where's the x-axis negative? Yeah, the x-axis is positive over here and negative over here. So I'm looking for a negative cosine. I'm only allowed right here anyways. So looking for a negative cosine, that's this spot. So what is my radian? 2 pi over. I'm about to erase it. Ready for number 3? Okay. Here's number 3. Sine, the inverse sine of 1. Inverse sine of 1. Where is y1 at? Guys, think about it. Where's y1? That's what I'm asking for, right? So, it's here. It's the only spot. What is my radian value there? Pi over 2. Okay, the next one, number 4. The inverse cosine of negative root 2 over 2. I have a negative cosine. Cosine is negative only on this side, right? And you're only allowed in this quadrant, quadrant 2. Only allowed here. So a negative cosine, these are my options. So it's this, which gives me 3 pi over 4, right? You getting it? 3 pi over 4. Okay, 5. We're going to throw you for a loop then. Alright, here's 5. 5 gets a star. I want the inverse sine of negative root 3 over 2. Careful. This one's a star for a reason. I want sine to be negative. Sine's y, right? So I know I'm here somewhere. Right? So I want sine to be negative root 3 over 2. Well, sines, these are all the signs, but this quadrant doesn't even matter. Y is negative down here. Okay, right. So y'all are going to call this 5 pi over 3. Is that what you got?
Yep.
And it's wrong.
What?
You're in the right spot. Okay? Well, we just talked about sine's graph is not, sine's inverse is not a function unless we just restrict part of it, right? So I'm only allowed in 1 and 4. Well, in order to call this 5 pi over 3, it meant you started here and you went 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, all the way here. That's how you name that 5 pi over 3, don't you? That's right. But is sine even allowed to go over there? If I get to travel through these quadrants, all of a sudden inverse sine is no longer a function, right? So I can't go that way. So if I want to call those any of these angles in this quadrant, any of them, yep, you have to remember they're the reciprocal. I mean, they're the flip. This is pi over 6, so this is negative pi over 6. This is pi over 4. This is negative pi over 4. Okay, this is pi over 3. So this is negative pi over 3.
That's tricky.
This is pi over 2. What's this one called down here then? Negative pi over 2. Okay, let me explain why one more time. Listen to me so you understand. When you get an answer that's in when you get an answer answer in quadrant 4. Okay, you're not allowed to get there by going. You're not allowed to get there by going this way. Oh my goodness. By going this way.
There you go.
Right? So in other words, you have to go, and the reason is because sign's not allowed here or here. So you had to go this way, which means you go clockwise, which means your angles are negative. Right? Okay. So with all that huge mess, the answer is negative pi over 3. Try number 6. Inverse sine of cosine of 7 pi over 6. This is a tricky one. It's really not too bad. Do this part first. Get this answer. Now, what I underlined in green right here just is cosine. Is it an inverse? No, it's a plain, let's go back and look at your first 3 problems you did. Okay? It is not, it's just a plain old cosine, not an inverse. So if it's plain old cosine, guys, you can travel the entire length of your unit circle and it doesn't make any difference. Because you're inside. There's no restriction on plain old cosine, is there? There's only a restriction on the inverse of cosine. There's only a restriction on the inverse of sine. Okay? This does not say inverse. So find it on your unit circle. Where is cosine of 7 pi over 6? It's right here. Right? And what's the cosine value? This. So now your new problem becomes the inverse of negative root 3 over 2. And you start all over. Now find the answer to that. Sine, you'll notice sine is negative. Sine's only negative here. So I'm going to look for a negative sign, which is this. And do not write 5 pi over 3. These 3 answers will never be, these 4 answers will never be an inverse answer. They will be a regular sine or cosine value. They'll never be an inverse. So what's the answer? It's this spot jumped to here. So negative pi over 3. Okay, you're all done. Try your worksheet that you have that you got me.